Good morning, guys. Good morning, guys.
Good morning, ma'am.
I think how are you? All of you. Hmm? Let me check how many people are there. Just wait for 1 to 2 minutes. Okay, I think we will start. Yes. All of you, good morning, guys. Your first lecture has not done, no? Maths?
No, ma'am.
Okay. माहित असतं तर मी पहिलेच म्हणून टाकलं. ठीक आहे. I know that you have from today you have a mock examination, na?
Yes, ma'am.
Yes, ma'am.
That is for your the first semester. Okay, and I think from 7th of March you have a university NSEM examination. Am I right?
Yes, ma'am.
8th March.
Be prepared,
8
guys.
March.
8 March, sorry. Yeah. महिला दिन बरोबर बरोबर ठीक है. Be prepared, guys. Study very good. All the best for your examination. Okay, and whatever if you have any problem regarding your first semester subject वगैरह तो आप subject teacher को पूछ सकते हो. Okay, कोई problem नहीं है. I think you know that, no? Let me know. Your all the lectures has been done, no? हाँ बोलो guys. Syllabus is completed, na, for first semester. ठीक है. Thank you, Raj Kate. Okay, now we will start for whatever we have covered. See, we have gone through the brief history of microprocessor. Okay, in that we have seen what do you mean by segmented model, what do you mean by flat model, then which are the different features of microprocessor, that is the 8086. Now I think we are in 386. Am I right? We are in 386 microprocessor. Okay, 386 microprocessor, the features of 386 microprocessor, that is, it is a 32-bit processor. Okay, it has a 8 general purpose 32-bit registers, like you have auxiliary and all this thing. That we will see, all the registers. Now, the instruction set of 386, I think I am just revising this because we have already done this. Okay, let me share my PPT first. Screen is visible, everybody?
Yes, ma'am.
ठीक है. Now this we have already seen. I just revised this. What we have seen. 386 is a 32-bit microprocessor. That's why it supports the 8-bit, 16-bit, 32-bit data operand. It has a 8 general purpose registers which having the size 32-bit registers. Okay, it is a upward compatible with all the predecessors. Like you have predecessors, like you have the lower version of the microprocessor. Then it has the modes like the real addressing mode, protected addressing mode, and virtual. That is the VM86 mode. Now there is 80386 applications under the protected mode in its virtual 8086 mode of operation. Okay. Now with the 32-bit address bus, the 80386 can address up to 4 GB. That means it has a 4 GB physical memory. Okay, and that memory is organized in terms of segments of 4 GB at a maximum. Okay, and it supports the total virtual memory near about the 4 GB. Now it also supports the paging concept. You have the multitasking is there, then the protection mechanism is there. We will see this concept. Okay, but these are the features. Even it has the 8 debug register, test registers are there for the hardware debugging. okay, and control. It has on-chip address translation cache memory is there. That is the on-chip cache memory they have provided, and the new concept of paging they have included in this version. Now it supports the 387. I think I have already explained the 387. 387 is the coprocessor. That is the NDP. That is the numerical data processor. It supports the numerical data processor. Numerical data processor means it does all the complex arithmetical calculations. Okay. It do all the arithmetical complex arithmetical calculations. So what will happen? Here it will perform all the numerical calculations, which will be some like you have algebraic is there and all that. So that will be done with the help of the coprocessor, and that coprocessor, the number of that coprocessor IC is the 80287 387, but for 386 it is a 387. Now we will go through the next, that is the functional block diagram. Oh, before that I already explained the flat model. Yes, flat model I have already explained. Am I right? I have drawn the last time one diagram. Do you anybody remember that diagram? Huh? Yes, right. Which address diagram I have already drawn that. You just go through that. Now next is the segmented model. It has the two types of model. First is the flat model and second is the segmented model. So in the segmented model, it has near about that is the segmented model. Segmented memory means what? It's logical address space. It's the memory. The IC is logical address space. Okay. So the processor here in this, you have near about I can say 2 raised to 46 byte. That is the 64 tetrabytes. Okay, it has the memory capacity, something like that. Okay, and the segment is a continuous address space where the segment size may range from near about from 2 raised to 32 bytes. Okay, that is the 4 gigabyte. But obviously it has the total memory is a 4 gigabyte. That's why it is a 2 raised to 32 bytes. Okay, so the complete pointer in this address space, it has the two parts. First, lower 16-bit and the upper 16-bit. Okay, so the segment selector, the first part is the segment selector. It has the 16-bit field. Okay, which identifies which address logical space is there. Okay, you are getting it. This is the segmented model. In the segment unit, it is a continuous address space. Okay, the segment size, it may be ranges from 0 to 4 gigabyte, that is 2 raised to 32 bytes. Okay, so a complete pointer in this address space, it has the two parts. First is the segment selector and second one is the offset. These are the concepts that will be useful in your instruction set of microprocessor. So segment selector, which is a 16-bit field, it identifies the segment and the offset. It is the 32-bit ordinal that addresses to the byte level within the segment. Okay, so this is the segmented model and the flat model. Now we will see the next, that is the functional block diagram or the architecture of 386 microprocessor. If it is visible to you guys, let me know.
Yes, ma'am.
So each part has been. Now see, this is the architecture of 386 microprocessor. This is the architecture of 386 microprocessor. Now the architecture of 386 microprocessor is basically divided into two main units. The first unit is called as the bus interface unit, and the second unit is called as the execution unit. I think you remember the 8086 architecture. Okay, in that they have the two units, bus interface unit and execution unit. I already explained you what is the function of that particular each and every unit. Okay, so same thing, only some few features gets added and the block diagram gets changed for the next version of the microprocessor. So this is the 386 microprocessor. Just go, I just read it, the everything whatever in your slide. Just read it. I will give the 2 minutes to read it. Read the diagram very carefully. Okay. Now the 386 block diagram, it consists of first is the central processing unit. Everybody has gone through diagram, or shall I give some time to read it? Let me know. Read it? Okay. Now this architecture, it has basically divided into 3 points or 3 parts, I can say. First is the central processing unit, second one is the memory management unit, and the third one is the bus interface unit. First is the central processing unit, second one is the memory management unit, and third one is the bus interface unit. Now, the central processing unit, it consists of the execution unit and the instruction decoding unit. Madam, आता instruction decoding काय आहे? That I will explain afterwards. But regarding that, I just want to tell you, whenever you give any instruction to the computer, okay, it won't accept directly. What it will do, the keyboard is a user interface between your the software or the user and your the hardware, sorry, the machine. Okay, so the keyboard is very important. So after giving the input through the keyboard, CPU will respond to you. CPU will respond to you. Okay. Now, how this responding will be done? Whatever the instruction you have given to the CPU, it will execute. But whenever, until and when you won't give any instruction, it won't do anything. Okay, so whenever you give any instruction to the CPU, it will execute that instruction. But you have to give the input through the keyboard only. You have to give the input to the keyboard only, through the keyboard. So keyboard is a user interface between your program, your user interface between your machine and the who is what you can say, a software engineer or the programmer or the user. Okay, and between your microprocessor and your microprocessor. Now, second one is the keyboard. Anybody know which IC is used for the keyboard interface? There is a one IC that is, anybody know this? 8279, that is the keyboard interface controller. That is the keyboard interface controller. Okay, now next, memory management. First is the CPU, that is the central processing unit. Second one is the memory management. Now the memory, that is, in short, you can say MMU, memory management unit. MMU, that is the memory management unit. And the third one is the bus interface unit. Now here, uh, central processing unit, it performs the operation related to your central processing and user interface. Okay. Now next is the memory management. Memory management will do all the operations related to your memory, processor's memory. And the bus interface, it will perform all the transaction between input output port and all the whatever, suppose there is some address translation is there or the data translation is there, then it perform all the interfacing, okay, between the two unit or between the IO ports okay. So this is the very basic thing. Now we will see one by one. Here you have just 1 minute, I want to tell you what do you mean by decoding. Anybody know what do you mean by decoding? Anybody know what do you mean by decoding? Anybody know the decoding? काय असतं decoding? कोण सांगेल मला? See, whenever you give the input to the processor, your laptop, it only understood your language. Okay, it only understood your language. Then what he has to do that whenever you type a K, he has to convert that into his own language. Okay, and then he will understood that language, and then according to that he will perform that particular operation. Okay, this is the one clue. बोला पटकन लवकर. तर डिकोडिंग मध्ये कसं असतं, पहिली सो whenever you give, suppose P is given to you or the K is given to the keyboard, you would understood user has typed the K. So what he will do? He will convert that instruction to his own language. That may be ASCII hex code. It may be in a binary format. That will be depend upon different applications. Okay. So that is nothing but the decoding. That means he is converting your language. That means he is converting its language, whatever the user has given the language or the instructions, into his own language. That means he has converted the user given instruction to his own language. That is a decoding. This is called as decoding. And whenever he accepts that instruction, that is called as the fetching. And execution means after decoding, there will be the .exe file will be created, and .exe file will be created, and then it will come. Okay, now he decode that instruction and convert into the .exe file. This .exe file will be the executable file. This .exe file will be the executable file. Okay, so fetch, decode and execute. So these are the simple three cycles or the fetch cycle of microprocessor. Now the block diagram. Here in the block diagram you have the arithmetical logical unit. Just go to here. Here, just see. My mouse is visible to you. Mouse is visible to you. Yes or no, guys? PPT आहे का व्यवस्थित visible?
Yes, ma'am.
Now this is a ALU. This is a ALU. That is the arithmetical logical unit. Now this ALU, it will have the registers file, but obvious for any arithmetical operation, it will take the help of all the registers. Okay. Then multiply. Here you have the all the arithmetical related calculations are there. All the arithmetical related operations are done in this ALU. Okay, control will control all the this baseline and all these things. Okay, now here first is the bus interface unit. The bus interface unit. काय असतं bus interface unit? This it has in the bus interface unit. You have the driver, you have the different drivers are there, then the trans receivers are there. Madam, trans receiver काय असतं? Why it is required? What do you mean by trans receiver? बोला पटकन. Trans receiver. What do you mean by trans receiver? ट्रान्स रिसीवर. अरे सिंपल मीनिंग आहे रे. बरं रिसीवर काय असतं? ट्रान्समीटर काय असतं?
Which include data bus and control the signals.
कंट्रोल सिग्नल्स. बरं, अजून याच्या व्यतिरिक्त कोणाला काय माहिती आहे का? Trans receiver is nothing but it accepts the data from the outside and it transmit or it convert into his own language and then transmit to the trans receiver accept the data. It transmit the data. It transmit the data, okay, and according to the format is given. According to the format is given. That is the transmitter. That is the transmitter. Okay, okay. Now the bus interface unit. It communicate with the I/O, with the input output read operation. आता इनपुट आउटपुट रीड ऑपरेशन म्हणजे काय? आता हे प्रोसेसर मध्ये झालंय का तुम्हाला? नाही झालेलं मॅडम. ओके, that we will take it. That we will take it. But just listen now. The bus interface unit. It is the interface of the processor with the outside world. With the outside world. With the outside world. Now, the bus interface unit, it has 32-bit address bus as well as 32-bit data bus. म्हणजे त्याची ॲड्रेसची साईज ही 32 बिट आहे, कारण आता प्रोसेसरच 32 बिट्स आहे. ठीक आहे. नाउ द बस इंटरफेस युनिट, it fetch the instruction from the memory and it put into the prefetch queue. It put into the prefetch queue. It fetch the instruction from the memory into the prefetch queue. Okay. Now the bus interface unit, it whatever the address, whatever the segment address has been generated for accessing the instructions using the whatever the IP means what? IP means what? instruction pointer. Okay, and EIP means extended instruction pointer. Just write down like this. IP means instruction pointer. EIP means extended instruction pointer. Now, this bus interface unit, it accesses the memory for the data and it manages the memory read as well as write operation. Read and write operation. Read and write operation. Okay. Now, next is, I will repeat it again, the bus interface unit. The bus interface unit generate the address for accessing the bus interface unit ने काय केलं, he has generated that address and that address will be converted into like your, or that particular is converted into a coding. Okay, it is converted into the coding, not actually coding but its own language. Decode केल्यानंतर जे काय असतं ते त्याच्यात ते convert करतं. Okay, now the next, it also accesses the memory for the data. That means it manage the read-write operation of the processor. It also perform the read-write operation with the I/O process. It also perform the read-write operations with the I/O addresses, with the input-output addresses. It has the data transceiver. It has the data transceiver to manage the data in both the directions and send as well as write the data bus, and according to that the timing diagram will be done. See guys, this particular what I can say on access of the memory. Okay, this is the particular access of the memory for the data. It performs the memory read and write operation. Okay, it performs the memory read and write operation, and according to that he will draw the pie chart, or you can say a simple diagram, not diagram, I can say a simple pie chart we will draw. Or the read write. If you know the format for that wave diagram, okay, that clock diagram, okay, that will be created by the read and write operation of the processor. Okay, so that is the read write, that will be coming over here. Read write operation. Okay, and that will be indicated by your that particular diagram that I will show you, like the signal diagram, okay. Now next is the prefetcher and prefetcher queue. Now whenever the prefetch queue fetch the instruction and stores into the first in first out, that is, in short you can say FIFO. In short, it is a FIFO. So as the name of the नंतर कॉल करते, लेक्चर चालू आहे. ठीक आहे. Okay, as the prefetch queue or the prefetcher is there, see, just see over here, I think here, prefetcher, limit checker, 16 byte code queue is there. Okay, this is the instruction. This is the instruction prefetch. Now this instruction prefetch, as the name state, it fetch the instruction and store into the first in first out manner. आता मॅडम फिफो काय आहे? फिफो काय आहे? कुठलं डेटा स्ट्रक्चर आहे?
क्यू
आहे, ठीक आहे. So it is like a queue only. It is like a queue only. So whenever the prefetch queue fetch the instruction, it stores into the FIFO manner in advance, and when it is being executed. म्हणजे आता समजा मला एखादी इन्स्ट्रक्शन एक्झिक्यूट करायची, ओके, मला म्हणजे मायक्रोप्रोसेसरला बरं का, तर whenever he want to execute that particular instruction, he has to put that instruction in a FIFO, like in queue, and then it has to be executed. Okay, so the prefetching instruction is performed by the BIU, that is the bus interface unit. That is the bus interface unit. Now next is the prefetch queue. Now the arithmetical logical unit of the processor, it performs the execution of the instruction at and that will be done at a high speed as compared to the other processor, as compared to the fetch instruction and also the other processor also. Okay, now prefetch queue. Now next is the execution. In this prefetch queue, you have the processor has to be wait, or it has to be halt for some time. Okay, after fetching it must be decoded. म्हणजे जेव्हा क्यू मध्ये इन्स्ट्रक्शन्स असते, that will be fetched first, okay, and then it will go in for the decoding. Okay, and then after decoding it gets executed, and then again after the execution of the first instruction, the second instruction gets fetch, decode, execute, fetch, decode, execute. Okay, now this is the prefetch. Now next is the registers. Now registers, I think I have already explained you what do you mean by. We have seen the one register set, that is the flag register of 8086 microprocessor. Okay, now there are some new registers has been added in the 80386 register architecture. First is the base register. The base, total 4 base registers are general purpose registers, instruction pointer, flag register and segment register. Now see guys, 8086 आपण काय बघितला, फक्त फ्लॅग रजिस्टर बघितला, बरोबर की नाही? येस ऑर नो? त्याच्यामध्ये पण जनरल पर्पज रजिस्टर्स आहेत, AX, BX, CX, DX. Okay, now we will go for the 386 register set. In that you have the base register, second one is the system register, third one is the debug register. Okay, okay, and then there are few more registers for this 386 microprocessor, that is the control register, test register, debug register, that we will see afterwards. Now we will go for the base register. In base register you have the 4 registers: general purpose register, instruction register, flag register and segment register. In general purpose register you have AX. Now we are going for the 32-bit microprocessor, that is the 386 microprocessor. So the size of the AX register is a EAX. E stands for extended accumulator. Okay, E stands for extended accumulator. So there are these are the 4 base register: EAX, EBX, ECX, EDX. Okay, now in this you have stack pointer, base pointer, destination index and source index. Now yes, any doubt is there? Any doubt is there? Let me know guys. You are getting? Say yes or no. At least say yes or no. Or shall I repeat it again? Shall I repeat it again? Yes, Prabal?
ma'am.
You are not getting?
No, ma'am, I understood.
Okay, okay. So I think there is no doubt. So there are the base registers. In that base register, you have the general purpose register, you have the instructions pointer, flag register, segment register. In a general purpose register, you have the AX, BX, CX, GX. Now these AX is the 16-bit, but we are going for the 386 microprocessor, which is a 32-bit microprocessor. The size of the general purpose register gets increased, but obviously my microprocessor size gets increased. By default, my register size gets increased. So it is called as the EAX register. It is a EBX register. That is the accumulator, extended base register, extended counter, that is the ECX, and extended DX, that is the data register. Now extended stack pointer, that is the ESP, extended base pointer, that is the EBP, extended destination index, that is the EDI, and source index ESI. Okay, ESI. So these are the general purpose registers. These are the general purpose registers. In now next the instruction pointer. Now again for 8086 microprocessor, it is a 16-bit instruction pointer. But here we have a 386 microprocessor. That is the instruction pointer is a 16-bit. Here the instruction pointer, the size of the instruction pointer is a 16-bit. Okay, and it is called as the EIP. EIP. Now the extended instruction pointer. Now next is the flag register, and the size of the flag register, that is the E flag register. Now you have the next is the segment register. The segment registers are your code segment, data segment, extra segment, stack segment. These are the basic segment registers. These are the basic segment registers. And in 386 there are two more segment registers gets added. That is called as the FS and GS. FS and GS. See, code segment, data segment, stack segment, extra segment. These are already in a 8086 processor. But in a 386 you have, it is a two more segment registers get added, and that is the FS and GS registers. Okay. Now next is the system registers. See guys, system registers are like your what I can say, a flag registers are there. That is the E flag registers are there. We'll go through one by one for that E flag registers. Basically, we have already seen the carry flag, parity flag, auxiliary flag. That will be available in 8086. But for 386, there are few registers get added. Okay, that we will see afterwards. Now, the next is, have you understood the function of each register? जब तक आप बोलोगे नहीं तब तक मैं आगे का कुछ ये नहीं, आपको अंडरस्टैंड हुआ है कि ईच एंड एव्हरी रजिस्टर व्हॉट इज द फंक्शन ऑफ दॅट रजिस्टर. बघा 8086 च्या वेळेला मी सांगितलं होतं की त्याचं काय फंक्शन आहे प्रत्येक रजिस्टरचं. Okay, so shall I repeat it again? The same function you have for the 386, even for the Pentium also. Let me know. Let me know guys, or shall I repeat it again, the function of each and every register? Huh? Let me know guys. कोणीतरी बोला. काय फंक्शन आहे आता मी सांगितलं तुम्हाला जनरल पर्पज रजिस्टर आहे EAX EBX ECX आहे काय आहे फंक्शन त्याचं व्हॉट इज द फंक्शन ऑफ दॅट guys see whatever I am teaching you you should get it फक्त बसू नका get it understood what is the function I know that this is a little bit difficult to understand it because here you just have to consider you just have to assume because they have already developed we are just learning the concept or the technical behind that let me know repeat करू का shall I repeat it again let me know guys हाँ प्रांजल I can't hear you प्रांजल हाँ let me know guys have you understood the function of each and every register put in the chat box because I can't hear it. Okay, thank you. Okay, now, okay, now the instruction pointer is a 32-bit register which is called as the EIP for 386 processor. That is the extended instruction pointer. What is the function of this? Function of this instruction pointer, it holds the offset address within the segment of the next instruction which is gets to be executed. What I repeated it. It contains the offset address. Within that offset address, okay, काय असतं? काय कुठला address असतो? It holds, it keeps the address within the segment of the next instruction, and that next instruction it gets executed. Okay, so the instruction pointer keep that address. Address. And here the lower 16-bit of instruction pointer contain the 16-bit instruction pointer. Okay. Now here you have for the IP, that is IP is for 8086 processor, but EIP is for the 80386 processor. Okay. Now the next is the segment register. Now the segment registers, that is you have the CS, SL, GS, FS and GS. These are the two new segment registers which are added in a 386 microprocessor. Okay. Now next is the registers. Now we will go for the we have seen the ALU, instruction pitches, the prefetch we have seen, then the paging unit, segmentation unit, then the control unit and the instruction prefetch instruction. Just together, guys. Instruction pre-code, that is after decoding where the instruction will stored. Okay, now next. Okay, now बघा आता this is the memory management unit. This okay, just wait. Okay, now just wait, I will just take a pen and I will show you. Just wait. Okay, fine. Now, ready. Okay. एक minute, I just want to show you one thing over here. Okay, now now see guys, this is my MMU, that is the memory management unit. This is my MMU. Okay, and this whole thing is my bus interface unit. This is the bus interface unit, and the whole thing over here. Okay, I have this is my central processing unit. This is my CPU. This is my bus interface unit. See guys, this is my BIU, that is the bus interface unit, and this is my MMU, that is the memory management unit. Now, why I am explaining this? Now, in the central processing unit, it will do all the prefetching, decoding, and execution, and whatever it is. It performs all the operation. In the bus interface unit, it performs the operations like interfacing, like the accepting the data from the input-output unit. Like see here, you have this whole. These are some pins. That pin diagram we will see afterwards. But these are some pins, and through this pin, it accepts the address, it accepts the instruction, it accepts the control signals, all the things. Okay. So that's why it is a bus interface unit, and this is the memory management unit, that is the MMU. Now it does the operations like related to your memory, like your paging unit and segmentation unit. See, segmentation is nothing but your logical memory. Okay, paging is your the physical memory actually. There is some physical memory there, and then that part will be done by the memory management unit. Okay. Now, in the register we have seen the batch register, system register, debug register. There are two more registers available in the 386 microprocessor, that is FS and GS. FS and GS. Okay. मी नंतर कॉल करते, माझं लेक्चर चालू आहे. माझं लेक्चर चालू आहे, मी नंतर कॉल करते, लेक्चर चालू आहे. नाही, ठीक आहे. Now the next is the instruction pointer and the flag register. Okay, the instruction pointer E flag registers are there. बघा आता EAX, that is the extended accumulator register, which is a 32-bit. But in that you have the AX register, which is a 16-bit, and AHL is a 8-bit. You are getting? See, I will just draw over here. See guys. See, I will just show you one register so that you will get it. Here is a EAX register. Okay. Now this is a 32 bit. My screen is visible, guys. Whatever I am explaining, I am drawing with pen. That is visible to you, everybody?
Yes, ma'am.
हाँ ठीक आहे. ओके ठीक आहे. सो EAX इथे 32 बिट रजिस्टर. आता EAX मध्ये हा माझा झाला AX रजिस्टर. ठीक आहे. हा AX रजिस्टर आहे माझा 16 बिटचा. बघा guys, get it understood please, because whenever you want to do the programming at that time you should know all this concept. Now this is the 16 bit register. If I take AH and AL, now this is my AH and now this is my AL. Now this is a 8 bit, AL is a 8 bit and here AH is a 8 bit register. Okay, so got it? This is AH and AL register. These are the, or I can say AH and AL register is a 8 bit register. So this is for 8 bit microprocessor. This is for 16 bit microprocessor. And now according to our syllabus we have the 32 bit microprocessor, that is the EAX register. Got it? Understood? Now similarly you have the instruction pointer, segment registers. Okay. Now what is the function of the segment register? It holds the segment selector value. Okay. It holds the segment selector value. Just remember this one. Okay. While it performing in a 3 modes, that is the real mode, virtual mode and the protected mode. Understood? Understood? Now this is the architecture of 386 microprocessor. This is the architecture of 386 microprocessor. Now we'll go through the one by one the system flag registers. Okay. In system flag registers we have the carry flag, control flag and all these things, and then we will go for the processing mode of 386 microprocessor. That is, you have the we have the protected mode, real mode and virtual 86 mode. That we will see it in the next lecture. Any doubt regarding this? Have you understood this architecture of 386 microprocessor? Any doubt?
No, ma'am.
Have you got it?
Yes, ma'am.
Okay, very good. Okay, the काही doubt नसेल तर I will stop over here. Now from today you have a mock examination, so be prepared for that. Okay, I will stop here. Thank you.